Again, welcome to DSRT 734 class. These lectures cover permutations and combinations. Our main objective is to determine the number of ways a group of objects can be arranged in order, and that is permutation. Now, determine the number of ways to choose several objects from a group without regard to order is combination. So with permutation, the order of items is important. With combination, the order is not important. Also, we're going to learn how to use the counting principles to find probabilities. So again, a permutation is an order arrangement of objects. And the number of different permutation of n distinct objects is n factorial. N factorial equal to n times n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1. And also a 0 factorial is always 1. And 1 factorial also is 1. Now, example, a 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1, which will give us 720. And also 4 factorial will give us 4 times 3 times 2 times 1, and that will give us 24. Now, example is given here. This is a permutation of n objects. So we have object of a 9 by 9 Sudoku number puzzle, and is to fill the grid so that each row, each column, and each 3 by 3 grid contain the digits from 1 to 9. How many different ways can the first row of a blank n by n Sudoku grid be filled? So it will be 9 factorial or n factorial distinct. So the solution will be the number of permutation is 9 factorial, which will give us 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it will be 362,880 ways. Now, the permutation of n objects, taking r at a time, is given as the following formula: Pnr equal to n factorial divided by n minus r factorial, where r is either less than or equal to n. So again, the number of different permutation of n distinct objects taking r at a time. So if I have 5 items, I cannot take 6 at a time. So that's why here we say r should be less than or equal to n. So if I have 5 items, the most I can take at a time will be 5. I can decide to take 3, 2 at a time from 5. Permutation, the order of items is important. So 1, 2, 2 is not the same as 2, 1, 2. Even we have 1, 2, 2, which means we have 2 2s and 1 1. But the arrangement of 1 2 2 is not the same as 2 1 2. Combination will be the same because the order of items is not important. So let's see an example. How do we find the NPR? So here they say find the number of ways of forming the 3-digit codes in which no digit is repeated. So we need to find a 3-digit codes and no digit is repeated. So in this case, we need to select 3 digits from a group of 10 digits. Remember, the possible digit is from 0 to 9. So we have 10. And we are going to take 3. So this means n equal to 10 and r equal to 3. So it will be p 10 3. So it will be 10 factorial divided by 10 minus 3 factorial, which will give us 10 factorial divided by 7 factorial. Then we can have 10 times 9 times 8 times 7, 6, 5, 4, up to 1, divided by 7 factorial, so 7, 6, 5, 4, 3, 2, 1. Then we can see the 7, 6, 5, 4, 3, 2, 1 will cancel the down. So our final solution will be 10 times 9 times 8, which will give us 720 ways. Now here we have 43 race cars started the 2007 Daytona 500. How many ways can the cars finish? First, second, and third. So this means only 3 cars will reach first, second, third. And we have 500 cars. So we have 43 cars. So the question here says 43 race cars started at 2007 Daytona 500. So our total N will be 43 cars, race cars. And we are looking for only 3 cars that will be first, second, and third. So which means R will be 3 and N will be 43 because we have 43 cars. So we have 43 factorial divided by 43 minus 3 factorial, which will give us 43 factorial divided by 40, because 43 minus 3 will give us 40. Then we have 43 times 42 times 41 times 40 factorial. Then the top 40 factorial will cancel the denominator 40 factorial. So the answer will be 74,046 ways, which is 43 times 42 times 41. Next is the distinguishable permutations. Here we say the number of distinguishable permutations of n objects where n1 are of one type and also n2 are of another type and so on is given as following: n factorial divided by n1 factorial times n2 factorial times n3 factorial up to nk factorial, which is k times. Here we will know that n1 plus n2 plus n3 up to nk is equal to n. So let's see how we can use this, solve this problem. A building contractor is planning to develop a subdivision that consists of 6 one-story houses, 4 two-story houses, and 2 split-level houses. In how many distinguishable ways can the houses be arranged? Now here we have 6 one-story, 4 two-story houses, and 2 split-level houses. So in total, there are 12 houses in the subdivision. So total N will be 12. The reason why 12, we have 6 one-story houses, 4 two-story houses, and 2 split-level houses. So 6 plus 4 plus 2 gives us 12. That's total N. But N1, which is the one-story houses, we have 6. N2, which is the two-story houses, we have 4. Then N3 will be the 2 split-level houses, so it's 2. So we use the formula 12 factorial, the total, divided by 6 factorial times 4 factorial times 2 factorial. And if we do this calculation, we get 13,860 distinguishable ways. Now let's move on to combination. As we said earlier, in permutation, the order of items is important. In combination, it's not. So we can see that in the formula of combination, we also divided by R factorial. The R factorial will remove the number of orders of the items. So with the combination, the formula is N factorial divided by N minus R factorial times R factorial. N factorial divided by N minus R factorial is permutation. Then when we divide it by R factorial again, we remove the possible combinations. So here we say combination of N objects taking R at a time. A selection of R objects from a group of N objects without regard to the order. So a question is given here: the State's Department of Transportation plans to develop a new section of interstate highway and received 16 bids for the project. The state planned to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? So we can see that just looking at the question, we can't use permutation here because, for example, if we have 3 people, James, William, and Michael, whether Michael comes first or James comes first is the same 3 people together. So the same thing applies to this company. And we have 16 bid. Any amount we select, if we select 4, 3, the order doesn't matter. So let's look at the solution. Here we need to select 4 companies. The name of the company is the order doesn't matter. So in this program, we have to use combination to solve it. So we are selecting 4 companies from a group of 16. So N is 16, R is 4. Again, the order is not important. That's why we use the formula 16 factorial divided by 16 minus 4 factorial times 4 factorial. So the 4 factorial remove again the possible repetition of the order of items. And finally, after calculations, our solution will be 1820 or 1,820 different combinations of the companies. Next, they say we should find probabilities. Here we have a student advisory board, which consists of 17 members. 3 members serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve any of the positions. What is the probability of selecting at random the 3 members that hold each position? Remember, here we have 17 members. So here there is only one favorable outcome, but there are 17 and then 3 members. So it will be permutation 17 and 3, which will give us 40,080. The reason why this is permutation, because the position here, 3 members serve as the board chair, secretary, and webmaster. So we may have James as a chair, but next time we can have James as a secretary, or next time we can have James as a webmaster. Now, if all the 3 will serve as a chairs, then we are going to do combination if their position is the same. Here we have different positions for the 3 selected members. So we use permutation. Now here we said to select now 3 positions can be filled. Selecting the 3 members, the probability, now we are looking for the probability. So we already get the possible outcome. So the probability will be 1 out of 44,080 or 4080, which will give us 0.0002. Next example, we have 11 letters consists of 1 M, 4 I's, 4 S, 2 P's. If the letters are randomly arranged in order, what is the probability that the arrangement spells the word Mississippi? Again, when we look at the question, they didn't tell us to use permutation or combination. But looking at the question, they say if the letters are randomly arranged in order, so this have to be permutation. So the first thing we look for is there is only one favorable outcome, and we have possible 11. And here we have the letters, 11 letters, 1 M, 4 I, 4 S, and 2 P's. And those are the factorials down. 1 factorial, 4 factorial, 4 factorial, 2 factorial, the possible letters each. And this gives us 34,650. 11 letters with 1, 4, 4, 2 like letters. This is again distinguishable permutation of the given letters. Again, just by looking at the question, as we said, if the letters are randomly arranged in order, this is in order. So we have to use permutation. In this case, since we have different 4 letters and we know the quantity of each category, it will be a distinguishable permutation. As we saw our previous example, we have a couple of houses, but they are different houses. So since we know the possible outcome, now we can find the probability, which will be 1 over 34,650. So that gives us 0.00029. Another example, a food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels of the toxin. If 4 kernels are randomly selected from the sample, what is the probability that exactly 1 kernel contains a dangerously high level of the toxin? Again, we have 400 corn kernels, and there's 3 kernels have dangerously high level of toxin. And if 4 kernels are randomly selected from the sample, what is the probability that exactly 1 kernel contains dangerously high level of toxin? So here we have to do combination. Selecting 3, 5 corn, the corns are the same corn. If a person, we have 3 people for the same position, then it's combination. Different positions, permutation, order. So here we have 6, 3, and 1. And the possible combination is given to us, which will be 10,349,790. Because again, previously it was 400, but 3 kernels have dangerously high levels. So we say 397 is left. First of all, 3 to 1 give us 3, and we subtract from 400. So we have 397 and 3. Now we have to find, using the multiplication rule, the number of ways of choosing 1 toxic kernel and 3 non-toxic kernels. So this will be combination. We have 3 and 1 times the combination of 3, 7, and 3. And that will give us somewhere 31,049,370. Because we know the first combination, that is the possible number of ways choosing 1 toxic kernel out of the 3. Then the second will be the possible number of ways of choosing 3 non-toxic kernels from 397. Because we take 3 from the 400. Now, using the multiplication rule, we can find a number of ways of choosing 1 toxic kernel and 3 non-toxic kernel. We multiply the combination of 3, 1 and combination of 397 and 3. Now, the number of possible ways of choosing 4 kernels from the whole 400 kernels will be 404. And that will give us almost 1,050,739,900. Again, we know we are using this the combination formula, which will be 400 factorial divided by 400 minus 4 factorial times 4 factorial. And that will give you 1,050,000,000. Now, the next is the probability of selecting exactly 1 toxic kernel is combination of 3, 1 times the combination of 397 and 3 divided by the total, which will be combination of 404. So if we do the calculation with the formulas, we get 0.0296. We already find combination of 3, 1 times 397 and 3 in our previous slide. That's the 31,049,370. Then the combination of 404 gives us 1,050,000,000. 50,739,900. So that should be the probability of selecting one toxic kernel. So that will be the conclusion of this lecture. Again, this lecture is focused on the concept of permutation and combinations. As we said, permutation, the order of items is important. Combination, the order of items is not important. So again, see you in the next lectures. Thank you.